Hello, welcome to this video. We are going to talk about timers and interrupt. So our main interest in this class is timer 0, and at the end of the class we are going to write a program to pause a pin. That's we are going to generate a square wave of 2 kilohertz on port B3 of PIC 18F26K22. So in programming in timers and interrupts, there are things that we need to know. First, we need to know that the clock source, there are two clock sources for microcontroller peak. So we might decide to use internal clock source or external clock source. While using internal clock source, we use the clock is 1/4 of the frequency of the crystal oscillator on oscillator 1 and oscillator 2 pins. So while using external clock source, it is different. So the basic register of a timer, we have two registers for timer depending on the timer we are using, whether 16-bit wide or 8-bit wide. So for the 16-bit wide, we have timer R, that's timer XL, where X can start from 0, 1, 2, or 3, depending on the number of timers present in the microcontroller. We have the low bit and the high bit, which are 8-bit wide each. So this we also talk about the TCON, that's timer control register. So timer 0 registers and programming. So look at this table here. This table shows the arrangement of timer 0 high and timer 0 low. So from bit 0 to bit 7 is for timer 0 low. Then from bit 8 to bit 15 is for timer 0 high. So TCON register, that's timer control register, is a 8-bit wide register for control of timer 0. So look at the table for timer 0 control register. We have a timer 0 on, that's bit 7, turns on and off control bit. So when it's high, it starts the timer 0. So we have timer 0 8-bit. So choosing 1 for this bit, we are configuring it as 8-bit mode, while choosing 0 sets it at 16-bit mode. So we have TOCS. This is the clock select bit. So this is the bit that you use to select whether it's going to be an external clock, that's from pin RA4, or internal clock using F oscillator over 4. So if you are using a 20 megahertz crystal with your microcontroller, so the frequency of the crystal is going to be divided by 4 to get the actual clocking frequency. So we have timer source edge select bit, that's the 4th bit. So if you want it increment on high to low transition, that's you have low to high transition. So we also have PSA, that's prescaler assignment bit. So this prescaler is used, I will talk about prescaler so in a brief, so that you know what prescalers are. Like for example, if you want to perform, like the timer register or bits are limited, so with the help of prescaler you can perform more time delay or more time operations. So we have we use bit 2 to 0 to set the prescaler value. So the prescaler value, if it's 0, 0, 0, that is 1 to 2. That's for the prescaler of this. So when you are not using prescaler, you set this bit 3 to 1. But when you are using prescaler, you set it to 0. Then you now use bit 2 to 0 to address the prescaler value you want. So like for example, find the value of timer 0 con. If we want to program timer 0 in 16-bit mode, no prescaler, use PIC That's use the internal crystal oscillator for the clock source, increment on positive edge. So you come back to this chart here. So what do we want to achieve? We want to set in 16-bit mode. So in 16-bit mode, that means our bit 6 is going to be 0. You see it? Bit 6 is going to be 0, configured as 16-bit mode. What else are we also looking for here? They said we are using internal clock source. So you also go to this place, you look for the internal clock source, is also 0. Bit 5 is also 0. So what else do we need here again? They said increments on positive edge, that's rising edge. So you come here, increment on rising edge. What do we mean by rising edge? Rising edge is from low to high. So we use bit 0 here. It's 0, sorry, bit 4 is 0 because it is incrementing from low to high. That's rising edge. So now this is the value we load to the timer 0 control register for this particular example. So I'll go to the next example. Find the timer's clock frequency and its period for various peak 18 base system with the following crystal frequency. Assume that no prescaler is used. So for A, 10 megahertz, remember we are using what? Internal clock. So you divide it by 4 to get the 2.5. That's the clock frequency. So the clock period is what? Frequency is what? 1 over what? Sorry, period is what? 1 over frequency. So you get 0.4 microseconds. So just for 16 megahertz, you get the clock frequency by dividing it by 4. You get 4 megahertz. Then the period clock period is 0.25 microseconds. So just as the 4 megahertz, the clock period is 1 second after 1 microsecond after the calculation. So we also need to know some things before we write our program on timer 0. So we need to know about the timer 0 interrupt flag. So this flag is raised when the interrupt rolls over from FFFF to 000. So this flag is set high. In 8-bit mode, when it reaches FFF, that's 255, it rolls over to 00, the flag is raised. So we look at this again in our example when we start programming. So we are going to talk about this INTCON, this interrupt control register. So there are some things we need to know about the interrupt control register. So I would like to talk about this maybe through the data sheet so that we understand what we are dealing with. So meanwhile, for you to use INTCON in your program, you have to, for you to write a timer program, you have to use INTCON. So we'll be making use of bit 7, bit 5, and bit 2 of the INTCON. Bit 7 is the global interrupt enable bit. That's this bit. Sorry, the image might not be clear, but I'll still open it with the data sheet. The bit 7, hold on, bit 7, hold on, let me get it from the data sheet so that it will be clearer to us. So we are looking at what? INTCON register. We are looking at INTCON register. Hold on. So we want to get the table clearly so that we can know what we are doing, so we can see it properly. Just hold on a bit. So hold on. Okay, here we are. So we come to the interrupt. We look for INTCON or anywhere we see interrupts. So that's chapter 9. So we come to interrupt, intcon. We look for the table. So just hold on. So, okay, this is the table. I hope this is clear now. This is the interrupt control register. So this is the bit 7 I was talking about. Bit 7 is the global interrupt enable bit. When set high, that's it enables all unmasked interrupt. When 0, that's disables all unmasked interrupt. Remember, in our program, in the exercise, we said that we are going to be using bit 7. We also be using bit 5, and we also be using what? Bit 2. So in this register now, bit 7 is for the global interrupt enable bit. Bit 5 is the timer 0 overflow interrupt enable bit, while bit 2 is timer 0 overflow interrupt flag bit. So these are what we'll be using. So for bit 5, for the overflow interrupt bit, when set high, it enables the timer 0 overflow interrupt. 0 disables the timer 0 overflow interrupt. Whereas the flag is used to used to check whether the timer has reached the maximum. Okay, so this is exercise 1. Assuming that a crystal is 10 MHz, generate a square wave of 2 kHz frequency on port B.3 of our target microcontroller. So before doing that, I've solved the program, the problem in the exercise. So this is exercise 1. I don't know whether you can see it, but the note is uploaded in the WhatsApp group, so you can go and get the notes there. So first of all, our target frequency is 2 kHz and our crystal is 10 MHz, and we are using what? Internal what? Clock. So we are going to use internal clock to solve this problem. So first, step 1, you find the period of the signal. Remember, period is what? 1 over frequency. So our period is what? 500 microseconds. That's 1 over 2 kilohertz. Step 2, half of the high and low portion. So we want to get this part of the signal. We want to get this part. So half of the high and low signal is what? 500 divided by 2, that's 250. Step 3 is what? Step 3, you divide the crystal frequency to get the clock frequency by 4. You get 2.5 megahertz. Then the clock period is what? 1 over clock frequency. You get 0.4 seconds. Step 4, you use this formula to calculate the time delay and also to get the value that we're going to load into our timer 0 registers. So from here, after calculating, we get FD8FF. This is the value you load into what? The timer 0. So this is the program, using the program that I wrote to get the desired value. So I'll go through the program. So I would like to come to my compiler so that you see it clearly. Okay, let me go back here. It's kind of clear, but working on the compiler interface will make us understand it better. So in writing interrupts, there is what we call the interrupt subroutine. So this subroutine starts from here, this part I highlighted. So this is the place where once an interrupt occurs, the microcontroller jumps to this place to run the interrupt program. Why this is our main program? So you already know we are using port B.3 as our pin. So what we do is that we are going to address the register tries B.F3 equals 0, setting it as what? We are setting it as output. Then then port B.F3 0, clearing the port. So we clear the port. Then answer B, remember we are using that as what? Digital. So we have to set answer to 0. You get. Then T0 con how did we get this T0 con? Remember, we used our table. Let's go back to the note. T0 con. How did we get the T0 con? So you use, this is our T0 con table. So in our example, we are using T0 con. So see, the first bit here, sorry, bit 7 is high. That's T0 on bit. We set it on. What else are we using? We are using it in the 16-bit mode. So our bit 6 is 0. What else are we using? We are using internal clock. So our bit 5 is 0. What else? Okay, we are not interested in the whether it's rising edge or low falling edge. So but we choose 0. Then we are not making use of prescaler values, so we set our bit 3 to 1. That is how we got this value you see here, 1000 1000. That is how we got the configuration of T0 con. Then we have this interrupt. Remember, I said in our program we'll be using the intcon 3 bits in intcon register. So I said the bit 7, which is the global interrupt enable pin, which we set high. We are also using bit 5. As I said already, the bit 5 is the timer 0 enable. Then we also have the timer 0 clear flag. So here, so this is how we configure it. We use it as digital. We set this. We set our T0 con. We set our int con. We now enable our timer 0 bit. Then we now load the values. You see, we have loaded FD8FF. So loading these values into this program, we have to load it at first. Then we now come to our void interrupt. We now check. So this is where you check. You check for whether the flag is raised. So you say if timer 0 interrupt flag bit is high, then clear the flag. You now clear it. This line is used to clear the flag. So we now reload the values of the timer after clearing the flag. Then this line is the line we use to pause the signal to generate the square wave. So this, I will explain this line briefly. It means that this line means that the original state of B.F3 is inverted each time the interrupt pin executes. So this interrupt executes every 250 watt microseconds. So this is how we got this particular values. So I'm gonna build the program. Build it. So we also we look for our Proteus file. That we've been using for this class. We open it from this folder. The Proteus file has been uploaded to the WhatsApp group. So you go there, you download the programs. So the Proteus file, while we wait for it loading, I also like to talk about this special icon here. This icon, this is the timer calculator. So I'm gonna talk about it later. So let's simulate what we have done. So while we wait for it, we go to our simulation. So I've already set it up. We are using ROB3. So this is the pulsing signal ROB3, which I connected to an oscilloscope, and also I've placed my signal frequency counter there to show you that it is actually pulsing at that frequency. So I run the simulation. The program is already there. So I run the simulation while we wait for the animation to start. So okay, hold on. Okay, you see the pulsing this thing. See the pulsing signal. You see this is at 0.2 micro. This is at 0.2 okay, hold on. Okay, this is like the frequency. of the signal being generated. See, it's close to 2000. You see the program is working. It's working based on our expected value. You see, it's working. You see, it's working based on what we want to achieve. Okay, that's for now. So we're gonna look at the timer calculator. So the timer calculator is a special tool. The link of this is, I've given the link to download this timer calculator. It's a property of Mikroelectronika. So for how to use this timer calculator, it eliminates the calculations that I did in my example at the beginning of the example. So here you choose the microcontroller, your target microcontroller. So we are using PIC 18. We choose the target frequency, that's 10 megahertz. Are we using timer 0? Yes, you choose timer 0. Then you now go back to our notes. So what is the expected, what do we want? What is the period we want? Our period we want is 250 microseconds. So this is what we want to load into the what will I call it? This is what we want to load into the timer, 250 microseconds. So we come here, we choose microseconds. We come here, we write what? 250. So we do what? We hit calculate. See, excuse me. The timer, see, the prescaler is 1 to 1. The timer 0 preload value is 64911, which is actually the same value we calculated here. See it in our program here, 64911. You see, it's the same value that we got. You see, then the timer 0, you see, is the same FD8F. This is the global enable bit. This is the timer 0 enable bit or set high. Then this is the void interrupt. So for you to do this now, you just copy this. You copy this program, copy it, you copy, and go to your compiler. I'm going to paste it. So you see, you copy it, you go to you create a new project, go to timer, you name it anything, timer calculate. You come over to this place, you choose the target microcontroller, you choose the crystal, that's 10 megahertz. You click next, you click finish. You come over here, okay, hold on, then we paste this. So this is the interrupt. This is where we are going to enter our code. We now come here, simply we come here, we now write what? Our lat b dot f3 is equal to what? lat b dot f3. That's to invert lat b dot f3. Then also, when you come to our main program, we also need to write our main program. So in our main program, we now write void main. So I want to show you another way of getting this. We write our void main. You open our void main function. Then we address the registers. We use our trace b.f3 port b.f3. Let me simply copy it. So we copy, we come over here, we paste our trace b.f3, our port b. That's just initializing the port. Then the next thing we do is that we call this function. We call it. So we call our init timer. We call our init timer 0 function. So calling this function means that we are carrying everything that is here. We are loading this into this so that it will perform the same. It will perform while the program is loading. It reads this timer 0 function. So this, when you look closely, you see that the same values that we have here is the same values that we have here. Just look carefully, it's the same values that we have here. So you just come to your main program, you now do what? You now say init timer 0 function. Okay, let me build the program. Let's see whether we are going to have errors. I build my program. You see completed successfully. So the program is compiled. So let's go to approaches. Then we change the program. Remember, we are now using what? Timer. We're now using let me check the location of the program. So hold on a bit. Let me check the location of the program that I just compiled. This okay, micro C programs. So I go to that location, micro C programs. Go to micro C programs. I go to my drive D. I go to micro C programs. I go to timer calculate, timer calc.hex. I load the hex. I load the hex file. I run the simulation. Where you see we get our expected result. This is our expected result. As you can see, this is what we are getting as expected. We get so thank you very much. Thank you. This is our expected result. So thank you very much. Thanks for watching. So if you have questions, you can drop your questions. There are 2 programs here, using our calculation method or using the software which I already told you about, the timer calculator. Thanks for watching.